Hello guys, welcome back to my channel, and today we're going to be talking about simplifying radicals algebraically. And then if you remember that in my previous video, we talked about simplifying radicals numerically. So basically today what we're going to do is exactly the same thing, but in this case we have some algebraic expressions involving. So let's get started. The first problem in this first problem. By the way, I would like to thank the mathbits.com for creating this problems. So let's get started with the first problem. And the first problem I see as simplify square root of 27 times x squared. So basically, so we know that x squared can be written as x times x. So basically, if I take square root of x squared, I'm gonna get just x. Then 27 can be written as 3 times 3 times 3. So I just come across with the first pair of the same numbers as a product. So 3 times 3 is 9. So 9 square root of 9 is 3. So basically the number left over, the number left over will be just 3. So this square root of 27x squared is actually equal to 3 times x times the square root of 3. Let's move on to the second problem. And the second problem, before we focus on the second problem, we see right here a product rule. So basically, what it states that the square root of a product is equal to the product of the square roots of each factor. So basically, we're going to use this product rule to simplify radicals. So let's apply this product rule into this example 2. So basically, square root of 50 a squared b cubed is actually equal to, after we apply product rule, square root of 50 times square root of a squared times square root of b cubed. So I can factor this 50 into the product of 25 times 2 underneath the radical times, these squares and the square root will cancel each other out. So this is just a times, and then I can rewrite this b cubed as b squared times b. So we know that 25 is the perfect square of 5. So when I take the square root of 25, I'm going to get 5. So I'm going to put this 5 out front. So basically 5 square root of 2 times a. And we know that b squared is a perfect square of b. So basically these 2 and the square root will cancel each other out. And b times what's left under the radical is just b. So let's put this in the simplified form, the most simplified form. So basically I'm going to multiply the numbers right in front of the square root. So 5a and b, so basically it's going to be 5ab. Then also I can rewrite, by applying the product rule, these two square roots under the same square root. So it's going to be 2b. So this is the most simplified form. Let's move on to the example 3. In this example 3, again, we're going to apply this same product rule because it's going to make our job a lot easier. So this is going to be equal to actually square root of 12 times square root of a to the power of x to the power of 8 times square root of y to the power of 10. So basically we're going to play with these square roots algebraically a little bit more. So I can rewrite the square root of 12 as 4 times 3, as you see that 4 is a perfect square, times I can rewrite this x to the power of 8 as x to the power of 4 to the power of 2. Because let's remember the exponents, if you see any power being raised to another power, so in that case we just multiply the exponents. Remember that 4 times 2 we get 8. The same thing for this square root, so y to the power of 5 to the power of 2. So since I know that 4 is a perfect square of 2, so basically this 4 will come out as 2, and we're going to put it out front. So basically 2 times square root of 3 times, and then these square and the square roots will cancel each other out. So what I'm gonna have is just x to the power of 4, and the same thing for the next square roots. These 2 and the square root will cancel each other out. So what I'll have, what's left is just y to the power of 5. So let's multiply the numbers. So basically 2 times x to the power of 4 times y to the power of 5 times square root of 3. So this is the most simplified form of the original square roots. Let's move on to the fourth problem. In this fourth problem, we have this problem a little bit differently. In this case, if you remember that for question 2 and 3, we've applied to product rule. So in this case, we're going to apply the quotient rule. It's much same as the product rule. So in this case, basically, I'm going to rewrite this original radical into square root of x to the power of 5 times y to the power of 4 and over square root of 81. So just look at the top. As you see under the radicand, we see the product of two algebraic expression, x to the power of 5 times y to the power of 4. So basically I can reapply the product rule for the top expression. So it's going to be x to the power of square root of x to the power of 5 times square root of y to the power of 4 over square root of 81. So we know that the 81 is just 9 times 9, which is 9 squared, so the perfect square of 9. So it just comes out as 9. So I can rewrite this x to the power of 5 as x to the power of 4 times x to the power of x under the radicand times, I can rewrite this y to the power of as y squared to the power of 2 over just 9. So we know that x to the power of 4 is the perfect square of x squared. So because it can be rewritten as x squared to the power of 2. So basically these 2 and this squared will cancel each other out. So what I have is just x squared times x times these 2 and square root will cancel each other out. So what I have is y squared over 9. So let's multiply the numbers to put it into most simplified form. So it's going to be x squared times y squared. Sorry. It is x squared times y squared times square root of x over 9. So this is the most simplified form of the original radical expression. Alright guys, thanks so much for watching and paying attention to this video. And in this video we've talked about how to simplify radicals, especially the ones involving algebraic expressions. Please stay in touch. There's going to be more video, there's going to be more content coming. Thanks so much.